And finally, one more problem for this particular section here on number 15. Let's say we have a television that costs $350. If we're going to add a 7% tax to it, what is the total cost of the television? Okay, it's one thing to find the actual tax. It's another thing to find the total cost. And what many students do, and this is perfectly fine, but it just takes a little bit longer, is they take so they find the 7% tax, and then they add it to the original price. And that will give them the total cost involved, okay? But I'm going to ask you guys to do something a little bit different, to think about this problem a little bit differently. I'm going to take the $350 and realize that I'm not actually paying 7% of that. I have to first pay the first 100% of it. I have to pay all of it, 100% of $350, and then I'm going to pay another 7%. So I'm actually paying 107% total is my total cost. All right, so I'm going to take $350 and I'm going to multiply it by 107%, which as a decimal, if I move the decimal 2 places to the left, will give me 1.07. So just so that we understand here, that 1 right here shows us the 100% of the original value of the $350 plus another 7% added that we're going to get. So I'm going to throw that into my calculator as 350 times 1.07, and that gives me $374.50. Okay? I would like you to show me that on a sticky note, but this time show me on a sticky note for, let's say, 8%. So go ahead and take the same television, $350, and I want you to show me on a sticky note how much that's going to cost if you are going to add an 8% tax on it. What's the total cost if you add the original price plus the 8% tax? What's that going to be? So now I'm going to introduce the concept of percent of change. All right. So I'm going to start off with this example of what happened to the price of gasoline from 1930 to 1960. It looks like from 1930 to 1940 it went up by 5 cents, and then it went up by another 5 cents, and then it went up by another 5 cents. And a lot of students will think that if it's going up by the same amount every 10 years, that it's going to be going up by the same percent. But there's actually some interesting math that happened here that make it so it's not the case. So first of all, the price increases 1930 to 1940 by 5 cents. Okay? And from 1940 to 1950, it also goes up by 5 cents. 1950 to 1960, it also goes up by 5 cents. However, let's write the ratio as a percent for each of these. So the ratio we're going to write as the amount of increase, which in this case is 5 cents, out of the original price, which was 10. So 5 out of 10, well, that's 50%. So that actually is a 50% increase from 1930 to 1940. All right, well, let's try that from 1940 to 1950. Again, it is a 5-cent increase. But this time, in 1940, the price was 15, the original price. So the amount of increase divided by the original price, 5 divided by 15. Well, that's actually 1/3, or 33.3 repeating percent. If I do 5 divided by 15 in my calculator, I'll get 0.3 repeating, and I get a very different number here. Wait, the percent's going down even though it's been going up by 5 cents each time. All right, let's try it again. So I've got 5 cents is my increase again, but this time my price in 1950, the original price before the change, was 20. This is 5 out of 40, which is 1/4, or sorry, 5 out of 20, which is 1/4, which is 25%. So it keeps going down. So in other words, the 5-cent change is happening the same amount each 10 years. However, the original price that we're starting from is higher each time, which actually means that the percent change is actually smaller because it's out of a bigger and bigger quantity as we go up. Okay, so compare the amount of increase for each 10-year period. Does the amount increase the same amount, less each year, or more each year? Well, it's 5 cents each time, so that's the same. But the percent of increase actually becomes less each year. All right. So why does the amount of increase are the same, but the percents are different? Well, if we look at this, we can basically see, again, we're taking the same numerator the entire time, but it's out of a bigger and bigger number. So a same change out of a small number is going to be a big percent change, but a same number out of a big number will be a smaller percent change. So I want you to take some notes on this, that we've just discovered that a percent change is found by finding the change, so that a change in price or the change in something, sorry, not divided by the new, that was wrong, divided by the original or the old. Oops, I'm missing a few letters there. Original. Okay, so it's a change over the original, or sometimes written as the change over the old. Okay, so percent change is the change over the original price or the old price. Okay, so let's go ahead and put this into practice. All right, the science club had 25 members and now it has 20 members. Well, first of all, if I'm going to, again, I'm going to do the change over the original. How do I find the change? Well, I had 25 and now I have 20. So actually, to find the change, let's actually add this in here. To go back to this part here where I was finding the change, how do you find the change? I actually want to take, so if I'm changing from like something that's say 100 and it goes 110, I actually take my new and I subtract my old, and that will find my change over the old. Okay, so again, percent change is new minus old over old. All right, so then let's go ahead and do this. So changes are new minus old. Our new in this case is 20. Our old was 25 over our old original price, which is 25. So I actually get a minus 5 over 25. Okay, I know that I can basically throw that in my calculator, or I can simply know that that can be reduced to 1/5, which is 20%. And there's a couple of ways to think about it. I can write it as a negative 20% change. All right, that's I can either think of it that way, or I could write it also as a 20% decrease. So I'm including here. I had to put the negative 20% change in there. And now I'm writing it as a 20% decrease. The negative is in front of the number. This one I actually have the word decrease to show the negative. Either way is a way of showing that. I actually think a 20% decrease makes much more sense to people rather than a negative 20% change. Okay, so what's the percent of decrease? It's a 20% decrease. All right, let's go ahead and try for another one. Now we've got the original is 20 and the new is 23. So again, I do the new minus the old, divide that by the old, and I'm going to get 3 out of 20. I can throw that into my calculator, or simply, again, I know this times 5, I'm going to get 15 out of 100, and I will get a 15%. So that is going to be a 15%, and this is a positive, so it's a 15% increase. Okay, let's go ahead and have you see if you can do questions B and C on your own, and then we'll compare them to the answers here. Okay, so comparing these two, both of these were the original prices going up from 50 to 67 and up from 12 to 20, so they're both increases. We get 30%, 34% and 66.6%. Repeating a percent increase. All right. Now I'm going to ask you to do number 4 on a sticky note and then do number 5 on the packet here and compare your answers here. Okay, so in 5A, we had a 40% decrease because the new is smaller than the original. In B, we have an increase because the new is more than the original. And in C, we have a decrease because the new is smaller than the original. Okay, now we're going to move on to number 6 here. And number 6, Nick is selling some t-shirts at lunch to raise money for a charity. If the t-shirts cost Nick 860 yen and he wants to sell the t-shirts at 25% over his cost, find the selling price of the t-shirt. And this one says give 2 ways to find the answer, okay? Now I know some of you are going to say, okay, I'm going to find 25% of 860, so I'm going to multiply 0.25 times 860. All right, throw that in my calculator, and I get 215. All right, my original cost of the t-shirt was 860 yen, so I'm going to add that because it's the original. I want to charge 25% over what it cost me, but so I need to add the original part there too, and I end up getting with 1,075 yen. So that's one way of doing it, is finding just the 25% over, add that to the original and get that. But what I want you guys to be able to do is do this a different way. I want you to actually, rather than multiply it by 25%, I know that the original cost of this t-shirt is 100% of the cost, and additionally I'm adding another 25%. I'm basically finding 125% of the price, which as a decimal is 1.25. I multiply that times 860, and I throw that into my calculator, and I get that same price, but a bit faster, of 1,075 yen. All right, so I want you to really be able to think about this in terms of the 100% issue. Is 100% plus another 25%. And if you think about things like that, that makes doing this kind of problem very similar to it, which is kind of going in the other direction. If Taylor sees a pair of shoes that cost 9,500 yen, but she has a coupon that is 35% off any pair of shoes, how much is she going to pay? Well, if she paid the 9,500 yen, then she would be paying the full price, or 100% of it. But she's not going to pay 100% of it because the coupon takes 35% away. If I start off with 100% and I take away 35%, what percent am I left with? Well, I'm left with 65%. So the easy way to do this one is to just multiply 0.65, which is 65%, times the 9,500 yen, and I get the final price all in one step here, 6,175 yen. Okay? The other way, which takes a little bit longer, is to find the 35% first of the 9,500. All right, multiply that, and that gives me 33.25. And then I take the original 9,500, and I'm going to actually subtract it since I'm taking 35% off. Let's see, and I get 6,175 yen again there. So I get the same answer both ways, but it's so nice to be able to basically do one step in my head and then throw it right into the calculator in one step into that.